The red ellipses and shapes that you're seeing are Lissajous figures. They're mathematical curves that occur when two harmonic waves interact at a right angle. The horizontal axis wave and the vertical axis wave combine to form different ellipsoid curves. By altering the combinations of the frequency and amplitude of the waves independently, we can produce a variety of curves. The setup to make this is simple. We have two wires attached to speakers in the two-dimensional XY plane, one on the x-axis and one on the y-axis. The wires attach to a mirror in the same way. One attaches to the x-axis and controls the horizontal movement of the mirror, and the other wire attaches to the y-axis and controls the vertical movement of the mirror. We can change the frequency of the sound waves being transmitted through the speakers, ultimately altering the frequency of the wave that moves the mirror. There is a laser pointer pointing at the mirror reflecting onto the wall. The interaction of the frequencies on the mirror make the point source from the laser appear as a circular pattern.
If we alter the frequencies being played out of the speakers to be direct multiples of one another, this gives us a variety of symmetric figures depending on the value of the multiple. When you see this figure, the x and y frequencies are the same, or in phase. This gives an elliptical pattern. Equal frequencies should form circles, but here our horizontal signal is stronger than our vertical one. Sonically, this is like playing two of the exact same note, but at different volumes. The wobbling of the ellipse that you can see is due to some electronic fluctuations in the signal generators. This is when the vertical wave is twice the frequency of the horizontal wave. We know this because the curve that has developed has two distinct peaks, forming a saddle shape. You can think about this like two instruments playing the same note, but one of them being an octave higher than the other one. We get 3 peaks when the vertical frequency is 3 times the horizontal frequency. And again, we get 4 peaks when the vertical frequency is 4 times the horizontal frequency. We get some more interesting figures if the frequencies being transmitted are not multiples of one another, which causes the resulting waves to be out of phase with one another. This is the way that we can visualize sound waves in music.
With all of this, try and visualize what is happening when sound waves interact in this song clip.
Today wasn't my typical day on RuneScape.
Oops, wrong clip!